Now we discuss some exceptional cases. In the preceding sections, we discussed some linear programming problems which may be called well-behaved problems. There may be a linear programming problem which has no solution exists or for which the only solution obtained is an unbounded one. Now we discuss some of such problems. Okay. Maximize z equal to 10x2 minus 2x1 subject to the constraints x1 minus x2 greater than or equal to 0, minus x1 plus 5x2 greater than or equal to 5 and x1 comma x2 greater than or equal to 0. So to draw the graph, we first consider the inequality x1 minus x2 greater than or equal to 0 and take the equality x1 minus x2 equal to 0. Since x1 comma x2 greater than or equal to 0, or since x1 comma x2 are restricted to the first quadrant only, the line x1 equal to x2 must be here. That is, since x1 comma x2 greater than or equal to 0, or since they are restricted to first quadrant only, we have the line x1 equal to x2 here. This is the line x1 equal to x2. Next, to draw the line minus x1 plus 5x2 equal to 5, we first consider x1 equal to 0. Then we get 5x2 equal to 5 and x2 equal to 5. That is, we get a point. If x1 equal to 0, we get 5x2 equal to 5 and x2 equal to 1. That is, we get a point 0, 1. Next, if x2 equal to 0, then minus x1 equal to 5 and x1 equal to minus 5. So we get next point minus 5, 0. That is, minus x1 plus 5x2 equal to 5 is a line passing through 0, 1 and minus 5, 0. So we draw the line minus x1 plus 5x2 equal to 5. That is, this is a line joining these 2 points. And we extend this line to first quadrant. And we restrict this line to first quadrant only. So, this is our line minus x1 plus 5x2 equal to 5. Now, we want to find our feasible region. For that, first consider x1 minus x2 greater than or equal to 0. The points which satisfy the inequality x1 minus x2 greater than or equal to 0 is the collection of all x1 comma x2 such that x1 greater than or equal to x2. x1 greater than or equal to x2. And this is our line x1 equal to x2. So, x1 greater than or equal to x2 എന്ന് പറയുന്ന പോയിന്റ്സ് എന്ന് പറയുന്നത് such x1 comma x2 must be here. ഇവിടെ ആയിരിക്കും x1 less than or equal to x2 എന്ന പോയിന്റ്സ്. Okay. Next, minus x1 plus 5x2 greater than or equal to 5. നമ്മൾ 0, 0 എന്ന പോയിന്റിനെ കൺസിഡർ ചെയ്യാണ്. x1 x2 0 കൺസിഡർ ചെയ്തു. അങ്ങനെയാണെങ്കിൽ 0 greater than or equal to 5, which is not true. So, ഇതാണ് ലൈൻ മൈനസ് x1 പ്ലസ് 5x2 ഈക്വൽ ടു 5 എന്ന് പറയുന്നത്. അപ്പം ഇതിൻ്റെ ഫീസിബിൾ റീജിയനിൽ 0, 0 വരില്ല. സോ നമ്മുടെ റീജിയൻ എന്ന് പറയുന്നത് നോട്ടായിരിക്കും. സോ ഈ രണ്ട് ലൈനിൻ്റെയും ഇന്റർസെക്ഷൻ ആണ്, ഈ രണ്ട് ലൈനിനോട് കോമൺ ആയിട്ട് നമുക്ക് വരുന്ന റീജിയൻ എന്ന് പറയുന്നത് ഈ റീജിയൻ ആണ്. ഓക്കെ, നൗ വി ഹാവ് ടു ഫൈൻഡ് ദ വെർട്ടിസസ്. ലെറ്റ് ഇറ്റ് ബി എ and we want to find the value of a. And a is a point at which these two lines minus x1 plus 5x2 equal to 5 and x1 minus x2 equal to 0 intersected. So, to find the value of a, we have to solve these two equations. So, from this we get x1 equal to x2 and we put x1 equal to x2 into this equation, and we get minus x1 plus 5, and we replace x2 by x1, so plus 5x1 equal to 5, 4x1 equal to 5, and x1 equal to 5 by 4. Since x1 equal to x2, we get x2 equal to 5 by 4 also. So we get a equal to 5 by 4, comma 5 by 4. Now we want to find the value of our objective function at a, that is z of a. What is the value of z? Z equal to 10x2 minus 2x1. So we want to find the value of 10x2 minus 2x1 at 5 by 4, comma 5 by 4. That is 10 into 5 by 4 minus 2 into 5 by 4 equal to 25 by 2 minus 5 by 2 equals 10. Okay. That is, we get the value of the objective function at a equal to 10. But there exists a point in the convex region for which the value of the objective function is more than 10. That is, if we consider a point some b equals 2, 2, then what is the value of z at b? Z of b equals 10 into 2 minus 2 into 2 equals 20 minus 4, which is greater than, which is 60, which is greater than 10. Okay. That is, we get the value of our objective function z at a equal 10. But if we choose a point as b equal to 2, 2, then the value of the function at b equal to 60, which is more than 10. So it may be concluded that the maximum value of z, the maximum value of 10 z equal to 10x2 minus 2x1 occurs at a point at infinity. Hence the problem has an unbounded solution.